Jai Hind everyone, I am Vaishali Rastogi from Department of Computer Science Engineering, AKGEC. So earlier we have learned about some scheduling algorithm in our first video, and now we are just continuing from there. So let's start. So we have left this topic in our previous video, so we are continuing from there. We have the topic of preemptive priority scheduling. So let's start with the topic. That first, before going with the preemptive priority scheduling, if I give you the example of non-preemptive first, then you can understand it better that what is non-preemptive, and then we will make it how we can preempt the priority scheduling. Okay, so first I am telling you about the non-preemptive scheduling. So non-preemptive priority scheduling, yes, so in this, so non-preemptive priority scheduling is nothing but a concept of priority scheduling with no preemptions. Means here we are only considering about the priority of the algorithm. We are not thinking about that if any kind of higher priority process comes and there is no preemption, then we will just take care of that. The current process should not get preempted. So in this algorithm, we are having P1, P2, P3, P4, P5, P6 and 7 process which are having some priorities around 2 to 10. Here 2 is representing as a higher priority and 10 is representing as a lower priority. And these processes are also having some kind of arrival time. Arrival time are not in a sequence of P1 to P7. We can see over here that P1 is the first at 0 time arrival. And now we can see that P3 is having at 1 arrival time. Again we can see that there is no sequence of P2, P3. Here we are having the sequence in P1, P3, then we can see that P2, P4, P6, P5 and then P7. So according to the arrival time, they are also having some kind of burst time. Burst time is also different of each process. We are continuing about towards the non-preemptive priority scheduling. So again, in earlier video we have seen that we are making some kind of Gantt charts for understanding the process of completion among all these process. Let's start with the Gantt chart. Let's consider the time at 0. So at 0 time, we can see that we are only having P1. P1 is having the burst time of 3 times. Means we have seen that no preemptions, non-preemptive. Means we are just moving according to the priority which is mentioned here. But we are also looking for the no preemption. Means if the lower process is under the CPU execution and higher priority process comes, first it will complete its task, then it will move toward the higher priority. Let's see. In here we are just going with the arrival time 0. In arrival time 0, we are having the process P1 which is having which are looking for the process for 3 times. Okay. Now we can see that after at 0 time we were having only P1. Now we can see that at 1 clock we have P3. So P3 will go in Gantt chart. So P3 required for 4. 3 already we have worked and we are going for the 4. The total is 7. Now we can see that according to the arrival time now we have moved toward to the 7. Now all the process have been come. So we will go for the next process which is having a good priority. So which is having good priority among all these process? We have completed P1, P3. So P3, after P3 we are having P6 which is having the higher priority among all this process. So P6 will go under the Gantt chart. P6 is requiring for 4 burst time. So 7 already we have done. 4 is basically complete 11. After all this P6 have been done, now we can see that we are having P2, P4, P5, P7. Which is having the higher priority? P4 is having the higher priority. So P4 will go into the Gantt chart. P4 is requiring for 2 times. So it is now 13. After this P4 has been done, we are having P2, P5, P7. Among P2, P5, P7, P2 is having the higher priority. So it will go into the Gantt chart for how much time? For 5 time, means it is total 18 now. Now we are having only P5 and P7. So P5 is having priority of 7 and P7 is having the priority of 10. You have already seen that the 10 is the lowest and 2 is the highest, means 7 and 10 is 7 is the highest priority. So we will go with the P5. P5 is requiring for 9. So now we are having as 27. Again we have only left with the P7. So now P7 will have the CPU for 10 time, means total is 37. So this is our Gantt chart. Okay, but now we are also looking for some values like completion time, turnaround time, waiting time and response time. Okay, so let's calculate all these values of, with the help of. So let's calculate all these values with the help of Gantt chart. First, we will go for the completion time. Let's find out what is the completion time for P1. We can see in the Gantt chart that P1 is completed at the time of 3. So here we will write 3. Let's find out the time for completion time for P1. We can see in Gantt chart that P1 is completing at 3. So here we can write 3. P2 is getting complete on 18. P3 is getting complete on 7. P4 is getting complete on 13. P5 is getting complete on 27. P6 is getting complete on 11. And the completion time for P7 would be 37. So this is the completion time value for each process. Now we will looking for the turnaround time. So here I am telling you two formulas for calculating the turnaround time and waiting time for any kind of scheduling algorithm. This is the common formula. You can write in short that TAT is equal to completion time minus arrival time. Okay, and for calculation waiting time, WT equal to turnaround time minus burst time. So this would be the formula for calculating the values. So let's find out. Here we can see that we are looking for turnaround time for P1. So turnaround time is calculating by CT minus AT, completion time minus arrival time. So completion time is 3, arrival time is 0. So what will be the value? 3. 18 minus 2, 16. 7 minus 1, 6. 13 minus 4, 9. 27 minus 6, 21. 11 minus 5, 6. 37 minus 7, 30. So this is our completion time for all these process. Now we are looking for the waiting time. As we have seen that waiting time formula is WT is equal to TAT minus BT. So let's find out the time. TAT minus BT means turnaround time minus burst time. So 3 minus 3 would be 0. 16 minus 5 would be 11. 6 minus 4 would be 2. 9 minus 2 would be 7. 21 minus 9 would be 12. And 6 minus 4 would be 2. 30 minus 10 would be 20. So we have got our turnaround time and waiting time. Okay. So now we are looking for the response time. Response time is nothing but the first time CPU getting minus arrival time. Means a process is coming for CPU allocation and it is having the CPU, but the value which time that it is having the CPU minus the time it arrived. Means if, let's suppose example, if we are having a process which arrived on 1 and but it is having the CPU when CPU clock time is 6. So what would be the response time? Response time is basically 6 minus 1. So it would be 5. 5 would be the response time. So let's find out the response time for this process. So first time P1 got CPU at 0 and it arrived at 0. So what would be the response time? 0 minus 0 is nothing but a 0. and P2 got the CPU at 13 and it arrived on 2, so response time would be 11, and P3 got the CPU at 3 and its arrival time was 1, so 3 minus 1 would be 2, and now we are having P4 got CPU at 11 and it arrived at 4, so response time would be 7. So for let's calculate the response time for P5. P5 got the CPU at 18 and it arrived on 6, so response time would be 12. Again P6 got the CPU at 7 and it arrived on 5, the response time would be 2. Again P7 got the CPU at 27 and it arrived on 7, so the response time would be 20. So we have find out the completion time, turnaround time, waiting time and response time for all these processes. Now what we need to do, we have to calculate the average turnaround time and average waiting time. So you all know very well, in our previous video have seen that how we will calculate the average turnaround time and waiting time. So you can, I'm just calculating the average waiting time, and this is the task for you, that you have to calculate turnaround time and you can comment your answer here. So average waiting time I'm just going to calculate. So let's add all these waiting time: 0 plus 11 plus 2 plus 7 plus 12 plus 2 plus 20. It would be 54, and processes are 7. So we will having around 7.7 as average waiting time, and average turnaround time please calculate and comment. You can comment over here. Now let's move towards the preemptive. We have already learned about non-preemptive. Let's move towards the preemptive priority scheduling. So preemptive priority scheduling, we are having this kind of example. We have seen that non-preemptive priority scheduling was what? It is just working according to the priority and it was not getting preempted due to any kind of reason. But here preemptive priority scheduling is something opposite to that. Preemptive is word that it will show that if higher priority process is coming and lower priority process under the CPU execution, it will get preempted for a time, until unless higher priority process will execute their task first, then the lower priority process will execute their task. Here we can see that the opposite scenario, that 2 is having the lower priority and 5 is showing the higher priority. Let's create the Gantt chart first, then we will calculate all these values for this preemptive priority scheduling. In preemptive priority scheduling, we also look for the CPU clock time. According to CPU clock time, at each second we will see that how many process we are having at arrival time, and we have to check the priority among them. So let's start with the 0. Now let's suppose that we are having 0 time at our CPU clock and we are just going to start. At 0 time we can see that P1 process, which are having 2 priority, also having the 4 burst time, is at ready for execution at 0 time. So we will give CPU to P1. After only 1 second, at when CPU is having clock time 1, we can see that P1 and P2 has been arrived because time clock is 1 now. So it has completed 1 time, so it remain 3, and again P2 has come because 1 second has been passed. Now it is also looking for 3 times CPU. So here the higher priority is having P2 process is having higher priority. So the CPU will preempt itself and will give the execution time for P2. So P2 will have after completion time of 1. Again this process will repeat. P2, now P2 is in under CPU execution. After 1 second, after 1 clock, it will see that after 1 clock, it can see that at time 2 we are also having up to P3 process. Now we can see that it is having priority 2, 3 and it is having 4. Now among all these processes, P3 is having the higher priority. So P3 will get the CPU and P2 get preempt by P3. Okay. For again we will go for the single time clock. Now it is just move towards the 0 and after 1 second it will get to 3. Up to 3 we are having this. Now we are having process P1, P2, P3, P4. P3 already executed completely. Now we are having only P1, P2, P4. Among P2, P1, P2, P4 we can see that P4 is having the higher priority. Okay, so P4 will get the CPU for again 1 clock time. It is 4 up to 4. At CPU time 4, all these processes have arrived. Now we will only check the higher priority and give the CPU to them. So again we can see that we are having P1, P2, P4, P5 in ready up to 4 time o'clock, and P4 and P5 having the same priority. At the time of same priority, the first process who has come will be considered as the first execution. So P4 we can see that it is requiring for 4 time and P5 is requiring for 2 time, but having the same priority. So P4 will get the CPU first for remaining 4 time, means total is 8. So it is completed. It is completed. Now we are having P1, P2, P5. Okay. So P1 is having priority 2, P2 is having priority 3, P5 is having priority 5. So P5 will get the CPU first because it is having the higher priority. So P5, it is looking for CPU for 2 time, means total is 10. It is also done. Now we are having only 2 processes, P1 and P2 is having the higher priority. So it is looking for CPU for 2 time, means 12. It is all done. Now P1, but it is having the lowest priority and looking for CPU for 3, means total 15. So this is all about the Gantt chart. Now we are going to calculate the completion time, turnaround time, waiting time and response time. I have already told you about the how we calculate the completion time, turnaround time, waiting time and response time. Let's calculate again. Completion time of any process, we can see over here that P1 get completed at 15, P2 completed at 12, P3 completed at 3, P4 completed at 8, P5 completed at 10. So this is the completion time for these process. Now we have to calculate the TAT, WT and RT. So I have told you about the formula that TAT is equal to CT minus AT, completion time minus arrival time. So 15 minus 0 would be 15, 12 minus 1 is 11, 3 minus 2 is 1, 8 minus 3 is 5, 10 minus 4 is 6. So we have got the TAT for all these process. Now we are looking for the WT, yani waiting time. Waiting time is equal to, I have already told you that TAT minus BT. Done. Now we have to calculate the waiting time for all these process. So waiting for time we can calculate by CT completion time. Sorry. Now we have to complete the waiting time. As we can see the earliest, the formula for calculating waiting time was TAT minus BT. So TAT, turnaround time minus burst time. Here we will consider the burst time of these which was given in the question. Okay. So for 15 minus 4 would be 11, 11 minus 3 would be 8. 1 minus 1 would be 0. 5 minus 5 would be 0. 6 minus 2 would be 4. So this is our complete waiting time for all these process. Okay, so now we will calculate the response time. I have already told you that response time means that first time CPU allocation minus arrival time. So this process, like calculate for the P1. P1 got first time CPU at 0 minus arrival time, which is 0. P2 first time got CPU at 1 and it is arrival time is also having 1, means 0. P3 first time got the CPU at 2, which is having arrival time is also 2. P4 first time got the CPU at 3 and arrival time is also 3, means 0. P4 got the CPU first at, P5 got the CPU first at 8 and arrival time is 4, means response time is 4. Now let's calculate the average waiting time and average turnaround time first. You can also calculate by yourself, but I'm just giving you the final answer so that you can verify that you are able to calculate the right turnaround time or waiting time. You just need to add all these numbers and divide by 5. So I'm just giving you the final answer. Average TAT would be 7.6. Average WT would be 4.6. Just match with it with your answer, then you can see that your answer is fine or not. Okay, so let's move forward. Now we are going towards the round robin scheduling. In round robin scheduling, we have only one condition, which is time quantum. So time quantums, which we are having only one condition, which is time quantum. We can represent time quantum as a TQ. In this question, we are having time quantum of 2. 2 is a number which is represented by the CPU, that for 2 seconds, every process can stay in CPU and get executed. After time quantum time size, this process have to wait for another one, and after the complete cycle, it will again get the CPU for limited time, which is 2. So 2 is the limitation for remaining in the CPU. Again, we are also having two kind of queues among all these process, which is ready queue and running queue. So let's start with the numerical part. This is what? A ready queue. And we are also having one running queue. Okay, so ready queue is nothing but the queue where process will stay for a temporary time, and running queue is the again what ready queue was ready queue is the ready queue is the queue where all the process will stay for a limited time, and running queue is again what we are cut lena. Ready queue is the queue where all this process will stay for a temporary time, and running queue is the again Gantt chart. Okay, so let's start with the running queue and the ready queue. For the time 0, we are having only P1 in ready queue. Okay, P1 in ready queue. The running queue will see the process from the ready queue. So here we are only having one process which is ready in ready queue. It is P1, which is will come in running queue. So for 5, but it is having the limitation of 2 time, means after 2 seconds the process will switch from running to ready queue, but at 2 time we are also having P2, P3 at ready mode, means P2 and P3 at running at the time of 2 seconds. Okay, due to this. Now P1 get executed, again P2 after coming in running queue, this process will get back to the ready queue. Okay, so P2, we can see it is looking for 4 and it will get a CPU for 2 time, means 2, it will be 4. Up to 4 all the process has been arrived. So P4 has arrived in ready queue. Now we this P3, because P3 is the next one in ready queue, will come to the running queue and P2 will go to the ready queue. P3 has been come, so P3 will be cut from the ready queue. It is now in running queue. So P3 is looking for 2 seconds, and also having time quantum of 2, means 0, 6. Okay, again P1 is in the ready queue, so it will come to the running queue P1, and P3 has been completed, so it will not go again into the ready queue. P1 is looking for 2, means 8 and 1, P1 completed. And again now we are having P4. P1 is also having 1 left with them, so P1 again will go into the ready queue. P4 is requiring for only 1 second, means it will get CPU for 1 second. Doesn't matter, we are having time quantum of 2 because it is having P4 is requiring for less time, so it will remain in running queue. Now we are having P2 in ready queue. P2 is looking for CPU for 2 time, means 11, and it get completed, so it will not move again to the ready queue. And we are having P1, which is looking for CPU for 1 time, okay, 12. So all these process has been passed and completed their process. Now we have to find out the completion time, turnaround time, waiting time and response time. So you can calculate by yourself and you can verify your answer with my answers. It will help you to practice with the good approach. Earlier you have find out that how I calculate the completion time, turnaround time, waiting time and response time. Here I am just mentioning the final answers. You have to calculate all these times and just verify with my answers. If you are not if you don't know how you have to calculate, just get back to the video. In earlier I have shown you that how I calculate the completion time, turnaround time, waiting time and response time. So I am just writing the final answers over here. You have to calculate these answers by your own, so that you can verify that you have learned this process or this kind of scheduling algorithm. Okay, these are the final answers for all these calculation. You just calculate by yourself and just verify with my answers. Again, I am giving you the opportunity to comment over here. You just need to calculate the right average waiting time as well as right turnaround time, and you can verify with these values. Okay, so this is your final task to do. So now we have learned all about the scheduling, and we are only left with the SRTF, which I will cover in our next video. Stay tuned. Thank you.